All right, here we go, chapter 4. We can go through this pretty quick, a lot of this. This says classify each triangle by its angles and by its sides. Do you remember the names for the classification by the angles? Just go by angles. Just list them. I'm not going to write them down. Acute, obtuse, right, and there's one more. Angular. We're talking about angles, okay? So we have those 4 we can choose from. What if it says classified by its sides? What are the names? Isosceles, equilateral, scalene, and I think that's it, right? Because isosceles is 2, right? Scalene is 0, sides equal, and equilateral are 3 sides equal, okay? Or is 3 sides equal. You got it? Okay, so let's take a look at triangle ABD. ABD. All right. So we want to classify it first by its angles, then by its sides. So look at this according to its angles. What kind of triangle is this according to its angles? Okay, we could say, well, we wouldn't say equilateral. We would say equiangular because we're talking angles. Now, you don't have to have the second one. You only need one for the angles, but there is another one. What's another option? Because all 3 angles would equal, but all 3 angles are acute angles. That's right. So you could say acute as well, couldn't you? So you could say equiangular, or you could say acute. Yeah.
I put acute equal angular for the first time, and you marked it wrong.
That's right. I'm not finished yet because you gave me 2 words that talks about the angles. It says by the angles and by the sides. Okay. So you could have either equiangular or acute. Okay. But then you need a second one. You need to classify it by its sides. Okay. Look at this triangle right here. According to its sides, what could it be? Right? You could say equilateral. All right, you don't need all 4 of these. You just need one for the angles and one for the sides, okay? I'm just giving you the different options. What's another one you could use if you wanted to? Equilateral is fine. It's got all 3 sides equal to each other, but there's another one according to its sides.
Is there like a specific order that you have to put them in, like sides first or angles?
Well, it says by its angles and its sides, so to me, I would put angles first, wouldn't you?
Yeah,
and then sides second.
Like
I didn't mark off for that, but sure. I mean, I would. I mean, I just think it kind of makes sense. It says angles and sides, so I would put the angles first, and then I would put the sides, wouldn't you? That's just me. I like to do things in order. But all right, what about the sides? Come on. We saw equilateral. Come on, sides. Don't just say stuff for the sake of saying stuff. Equal side killer? I don't know if I talked about that. Come on. 2 sides are equal, right?
Isosceles.
Okay, thank you.
Wait, ABD? Aren't all sides?
Yeah, but at least 2 sides. Isosceles is... Don't talk, please.
I'm sorry.
Isosceles means if at least 2 of the sides are equal, then it's isosceles. So if you have a triangle with all 3 sides, at least 2 of the sides are equal, right? So that's what isosceles means. So you don't have to have all 4 of these. You can just have equiangular, equilateral, or you could have acute isosceles, or you could have acute equilateral. Now, Alyssa said she put equiangular and acute, and I marked it wrong. Why did I do that? Because this is only talking about the sides. I got to talk about the sides and the angles. You got it? Okay, let's go a little faster. Look at triangle ABC. Watch, ABC. I know this is a little small, but that's actually a right angle right there at angle B. Big hint. So, according to its angles, what kind of triangle is that?
Right.
It's a right triangle. Okay. Now, according to its sides, it's scalene because that has 1 arc. This has 1 here and 1 here, which means it's double this. This has 2, so I can't tell that any of those sides are equal to each other, can I? So if no sides are equal to each other, we call that scalene. All right, it's just a matter of knowing what these words mean. It's not that hard, the math. There's no real math involved at all, is there? Okay, what about BDC? Where's BDC? BDC. So it would be this triangle right here. By its angles, let's go angles first. What would it be? Yeah, I would say obtuse, because that angle right there is absolutely obtuse. How do you know it's obtuse? Just because it looks like it? Not really, because you got a right angle and a little bit more, right? If you have a right angle, that's 90. You got a little bit more, that's obtuse. More than 90, right? Okay, so it's an obtuse triangle. Okay, what about by its sides? Look, that has 1 tick mark, and that has 1 tick mark. That's isosceles. Exactly right. So there's no other options for this. That's the only thing that could be. We got it? All right, that was easy enough. Let's take a look at number 4. Number 4 says triangle FGH is an equilateral triangle. So don't know. Do you need to really draw it?
No.
Nah. Okay. So it's equilateral, which means what's true about all the sides?
They're equal.
They're all equal to each other, okay? So look at this. I've got this side, I've got this side, and I've got this side. All three of those sides are equal to each other. So in order to solve for x, and look what it says. It says find x and the measure of each side. So we've got to find x first. I could take any combination, any two of these, in any combination, set them equal to each other, couldn't I? And I'll get the same answer, all right? I don't know. Which one you want to do? Let's do the first one and the third one. Is that all right? It's probably the easiest one. 2x minus 2 equals x plus 5. It doesn't make any difference. You could do these two. You could do the first, and we already did those. You could do the first two. It doesn't make any difference. You still get the same answer for x. Subtract an x from both sides. Add a 2 to both sides. X is 7. Are we finished? Do we go to the next problem? No, we don't, because it says find the what? The measure of each side. Now, all we got to do really is find the measure of one side, because the other two are going to be the same. Why? Because it's equilateral, right? So if x is 7, what's fg? Let's write this.
12.
Fg is 7 plus 5, which is 12. Okay. Now, without doing any math whatsoever, what's gh equal to?
12.
What's fh equal to?
13 minus 1.
Which is 12. 14 minus 2. All right?
Ooh.
Actually, yeah, that's right. So there you go. So everything that's circled right there is your answer. That's pretty simple. I don't think we had too much trouble with that, but I just want to make sure I cover everything so nothing is left unturned. There we go. Is that better? All right, let's see. What's this? Isosceles triangle. So, again, do you even need a picture for this? I was going to draw a picture. I don't think you do, because look, it says that LM equals LN, right? It's isosceles triangle. So what are you going to do? You got LM, you got LN, so what's the obvious thing to do, I think? Set them equal to each other. I mean, to me it's obvious. I don't know. Is it obvious to everybody?
This is fun.
I hope. I hope it's obvious to everybody, right? Because it says LM equals LN.
Why do we have a
So you
Y?
take what... It's not a Y.
Oh.
It's an X. I just didn't draw it perfectly. All right, so let's do this. Subtract 2x from both sides, add a 2 to both sides, x is 3. But we're not finished there, are we? Got to find the sides. Let's find LM and LN. So let's just let's do LN first. Is that right? So LN. Oops, my writing's terrible.
Hi.
You'd think I'd get better at writing on this thing. I think I'm getting worse. So anyway, LN is what? 2x plus 1. So 2 times 3 is 6 plus 1 is 7. Now, LM, without doing any math whatsoever, it's going to be what? It's going to be 7. Do you agree? Because they're equal to each other. Now, we do have to do a little math to find MN. Not that big of a deal. 5 times what? 3, right? Because x is 3 minus 2. Yep, 15 minus 2, 13. And there you go. So there's that, and that. So 4 answers for those problems, right? Easy stuff. Don't you wish it was harder than this?
Nope, not really. Actually, I do. We should show some proofs.
I literally just learned.
All right, let's take a look at this. We're trying to find angles 1, 2, and 3. So here's angle 1, here's angle 2, here's angle 3. In the other class, let's draw it out. Is that all right if I draw it? Just make it a little bit bigger so that we can see a little bit better. So it kind of goes about like that. Something like that. Something
Mr. Hamrick, I'm going to start a
like
college.
that. College? Okay, good. Mr. Hamrick University.
I shall. Yeah.
University of Handy.
What is this? 35. This is 39.
I got this.
And this is 58. Alright, so here we go. Look, the first one's, I don't know if it's a harder one or not, but it's the one that we learned a little theorem to. Look at angle 1 right here. Let's find angle 1. Angle 1 is an exterior angle to this triangle. Well, it's an exterior angle to this one as well. But it's an exterior angle to this triangle, isn't it? What did we learn about the exterior angle? Remember we had a theorem? Okay, what do we call them though? We didn't say opposite interior, remote, right, to the sum of the remote interior angles. So that's a simple theorem, listen to me. It's a simple theorem, I mean simple math-wise, but you got to know what it says. The exterior angle is equal to the sum of the remote interior angles. So the angle that's furthest, the two angles that are further away from angle 1 in this triangle are my remote interior angles. Just add them up. That's angle 1. Go ahead.
Couldn't you
Or
just
if
do
you
like
forget that, if you add the
Oh.
minus the 180,
that? Well,
that's
that.
supplementary to
You
that,
could do that.
so you could subtract it.
Alright, stop.
Yeah, what I did was I just did the 58 plus 39 and subtracted that from 180 to get the.
I know, that's what she was saying.
Yeah, that.
That's exactly what she said. Okay? So anyway, I like this way. I just like adding two numbers together. That was easy, right? And so I get 97. Could you do it another way? Yeah. I've said all year long, there's usually more than one way to do these problems, okay? On this one, I just kind of think that's the easiest way, me personally, okay? If you want to do it the other way, fine with me, okay? If you want to find this angle, take it away from 180 to get this, that's okay. Because either way, it doesn't make any, the work's not going to be any more difficult because now I got to find angle 2. So how do I find angle 2 once I know this angle 1 right here? Subtract it from 180. So you end up subtracting from 180 either way, right? So it doesn't really make much difference. But I don't know, that's just how I like to do it. So angle 2 is just 180 minus 97. And so that's 3, and that's what, 8? So that's 83 degrees. So that angle is 83 degrees. Okay. Let's see. You could find angle 3 now. You could do it a couple ways. Look, this is an exterior angle to this triangle. It's 97, right? So this one plus this one equals 97. Did you think about doing it that way? In my other class, it was CP, what I did is I took 83 and 35, added them together, and took away from 180. But that's 2 steps. If you know that exterior angle theorem, angle 3 is going to be what? 97, angle 3. 97 what? Minus 35. You agree? So 2 and so 6, 62 degrees. Don't you think it's easier just doing one subtraction problem than adding 2 things together and taking away from 180? That's 2 things you had to do, where here it's only 1 thing you had to do. That's why they teach you the theorem. Okay? That's why they taught you the theorem, so you can only do 1 step instead of 2 steps. Isn't that nice of them? Okay. All right, enough of that. Let's go to 9 and 10.
Why do people make the test not to scale?
Just to get you to think about what the theorems really mean and really say, and make sure you know how to use the theorems. I don't think there's any problem with that. Let me try to get rid of all these circly things. There we go. Clean it up a little bit. All right, let's take a look at number 10. Here we go. Here's the key to this. You may not think this is important, but this really helps you out a lot. It says polygon ABCD is congruent to polygon PQRS. You may look at that and say, oh, okay, big deal, they're congruent to each other. But it's very helpful to you, okay? Just them labeling it like this is very helpful, because what does it say about angle A? Angle A, just looking at this, not even looking at that picture, cover up that picture right there. It equals angle P, right? So just seeing that information up there knows that angle A and angle P are equal to each other. So take a look at what I have. I got angle A and I got angle P. And now I can solve for x by knowing that those two are equal to each other. Would you agree? So what's that? 2x plus 4 equals 100. Subtract 4. That's what? 96. Divide by 2, and that's 48, I believe, isn't it? Yeah. So x is 48. Simple as that. Look at this one, DC. Okay? Now, really, I guess there is an option, right? It could be 12 or it could be 10. All right? Listen to me. Now, if you look at it to scale, I mean, that one looks shorter than that one. That one, yeah, it looks like that one goes with that. But if you're not sure, if you look at it, you can't really tell. What do? You look back here and look. Look at CD. CD is this one right here. What is CD equal to over here without looking at the picture? RS. So what's this right here equal to? It's equal to 12. So if you're not sure about it, go back up here, see which ones match up. That's why that part's very important. Everybody understand that? All right, so let's do that. What's that? 3y minus 3, and that's equal to 12. That's 15, 3, 5, right? All right, there you go. Simple stuff. I told the last class I wouldn't put proofs on the test. So if you don't mind, do you mind that or not?
Yeah, I do mind.
Leah said she wants to have proofs on the
Yes.
test. No.
Yes, that's what I told my friend.
All right.
Lisa innocent.
Leah says, "Don't blame me." All right, so we won't put proofs on the test. Okay, so
If you
let's not
really
worry
love
about
us, you wouldn't
those.
put proofs on the test.
You're probably right, but that I guess that tells you something.
Oh.
Yeah, it does.
He
but-
burned you.
Touche.
You're in the same class.
Oh.
Need some ice for that burn?
No.
No, it already melted, so.
All right, let's scooch this up a little bit, get all that stuff out of the way. Let's make this a little bit bigger so I can see it.
That's a little big there.
Yeah, it's not super clear, but that's okay. All right, let's take a look at this. You know what? That's a little small, so let's, I can draw that probably pretty easy.
What about that?
All right, that's close enough. Are we paying attention? Look, that's 92 degrees. This has 2. That has 2. This has 1. This has 1. A, B, C, D. Okay. Find measure CAD. So where's CAD? It's this one right here. So what do you think? Well, first of all, these two, I don't want just answers, okay? I want to know what you're thinking as far as getting the answer, not what the actual answer is. Look, these two sides are equal to each other, right? So what does that tell you, Alyssa?
Well, because the sides that are equal, you just.
Come on.
Since the sides are equal, then angle A is equal to angle C.
Are you really want to say angle A here? Because how do I know which one you're talking about? DAC.
And it is equal to well, ACD.
Okay. Yeah, ACD, that's fine. Yeah, these two are equal to each other because the opposite angles of equal sides are equal to each other, right? So these two are exactly the same. You know, this is 92 right here, right? So what do we do to find either one of these? 180 what? Minus 92. And so that's 8 and that's 8. So that's 8. So these two, they're not both 88, are they?
No.
They both add up to 88, and they're both exactly the same. So you're right. You just divide that by 2, and you get 44. Okay, so that means that angle is 44 degrees. Tell you what, just for fun, we'll put that down here too. We might have to use that. Who knows?
This is really fun.
All right, so that's angle what? CAD. That's our first one. Let's find angle ACD. Ah, we just found it. How about that? We did need it, didn't we? So that's at angle 15. That was easy. Now look, if you didn't get 14 right, you're not getting 15 right. So you got to be careful with those.
Or you're not getting 16.
Or you're not getting the rest of them either, probably. Okay, look at 16, ACB. ACB, that's this big old, yeah, that's an easy one. Big old obtuse angle right here. So what is it? 180 minus 44, right? 180 minus 44, and that would be 136, right? So that's this angle right there, 136 degrees. All right, so we got that one. What about 17? Angle ABC. ABC. There you go. See, that's the Michael Jackson that I used to like. Yeah, when he was a little kid. That was back in my time. They had a cartoon on
Jackson 5.
the Jackson 5. Yeah, I love that.
He was way better when he was younger.
Oh, he's way better when he's
He
younger, yeah.
looked better
He was.
too.
No, it's like his best song is just.
All right, here we go. Let's do this. So now look, to solve for angle ABC, this one right here, we do exactly the same thing as what we did on this first problem, isn't it? All right, so we just go, or you could do this. These two add up to be what? Here's an exterior angle. This might be a little easier to do. Watch. These two add up to be the exterior angle, 44, right? So these two add up to 44. They're both exactly the same, so what do you do with them? Divide them by 2, so that's 22. That was kind of easy, wasn't it? It's nice looking for that exterior angle thing. A lot of times we don't think about that because you're not, really used to it. But if you use it a lot, it comes in handy when you have a triangle with an exterior angle. We good with that?
Easy.
Okay, good. All right, this one says name the missing coordinates of the triangle. So take a look. These two sides are equal right here, right? And let's see what we've got. So if you come over here, Matthew. So watch, if we come over here, how far did you go? You went over 2a, you went up 0, didn't you? Okay. What else do they tell you? Is that all they tell you? So if these two sides are equal, I think we got to make a little assumption about this, don't we?
Yes. No.
Yes.
Because how do I know that isn't slanted over here? Let me put a right angle here. I think there should probably be a right angle right there.
On the test?
Okay. Did they? I made up the test. So I probably did a typo.
That's
So my guess is that there probably should be a right angle right there. Now, if there is a right angle right here and these two sides are equal, look what we have. We've got, look, if these two sides are equal, these two angles are equal, right? So look what I got. I got angle, angle, side, don't I? So what's true about these two triangles? They are congruent to each other, which means, now, the reason I went through all that stuff is I don't want to make any assumptions about this. Now, it sure looks like this is the same distance as this, doesn't it? Okay, but the reason we know it's the same distance is because the triangles are congruent, and by corresponding parts, these two sides would be equal. So watch. If I went over 2a to the right, how far did I go over here if that's the same? Because this and this is the same. So that's negative 2a, and how far up did I go? 0. Now, if this is 2a this way, this is 2a with this way, and this is the midpoint, where are we up here on the x-axis? No, on the x-axis. We're 0, right? Okay. Now, about how far up are we? Well, we don't really know. Okay, there's no way to say it. So let's just call it B. You could call it B. You could actually call it anything you wanted to.
Can we
All
call
right?
that anything we want?
All right, that's what we call it, anything. Call it anything. All right, so anyway, you could call it B, you could call it 2B, it wouldn't be marked off. It's just got to be 0, comma, something. There's no indication of how far up we go according to the information we've been given here. And that's it. It just says name the missing coordinates, that's all you got to do. All right? It's not too hard, is it? All right, let's go to 19. Here we go, number 19. It says an isosceles right triangle, okay, with legs a units long. So let's do this. Let's make a little xy coordinate. And let's scooch it over so that's right in the middle. There we go. Okay. And what's it say? Make an isosceles right triangle. And let's make this just like a little thicker.
This was hard for me to draw.
And let's make it red. Okay. So we're going to make an isosceles right triangle. So let's see, make a right triangle. So we go to there, and then we'll just eyeball this. Tell me when you think this length is the same as that.
That's too long.
I'd say that's pretty close, don't you?
That's a little long.
All right, you get the idea? Let's just scooch this just a little bit, just so. There we go. Can you see the difference between those two right there? Okay. And we're going to make a triangle out of it, so it's going to go to here. Everybody with me? So let's see, and it says with the legs a units long. So that means if I started here, this is a good place to put it. So what would that point right there be? That would be 0, 0. Okay, it's fine. So look at this right here. Now the legs, what are the legs? It says it's isosceles and it's right. So that's a right angle and it's isosceles. So that leg and that leg are equal to each other. It says the legs are a units long. So what is this point right here?
A0.
It's A0. So don't write 2A0, right? Just write A0 because it says the length of the leg is A units long. Make sense? So this point up here then would be
0A.
0A. And that's all there is to it. That was easy, wasn't it?
Okay.
You like those, don't you?
I actually do like those.
And it just says position and label the triangle on the coordinate plane. And I've done exactly that. I've positioned the triangle where it's supposed to be. I've labeled all 3 vertices, and that's all you have to do. All right, let's try the last one. All right, here's the situation. We got a triangle. It's an isosceles triangle, so this side is equal to this side. And we're joining the base vertex, which would be right here, to the midpoint of the leg of the isosceles triangle. Okay, so here's your 2 legs. These 2 are your legs because they're the 2 equal sides. Here's the midpoint, here and here. And what am I doing? I'm joining. Let's do a different color here. I'm joining this base vertex to that midpoint. And I'm taking this base vertex to this midpoint. And what am I trying to do? I'm just trying to show that the segments joining the base vertices are what?
Congruent.
Are congruent. So the 2 green ones, I'm trying to show that the 2 green ones are equal to each other. Does that make any sense?
Yes.
All right, so let's label this. What would I call this point right here? Yeah. Let's make this black again. So 0, 0 right here. What would I call this one?
2A.
Yeah, let's go 2A. Since I'm doing midpoint, it's a lot easier taking half of 2, isn't it? Than half of A. Would you agree? 1A. So I'll call this 2A 0. What am I going to call this one right here?
Negative 2A?
Yeah, I'm going to call it negative 2A 0. All right. And what about this point up here?
It's called a
0,
So,
2.
yeah, let's call it 2b, since again I want to take half of that, so I'll go 0, 2b. Is that all right? All right, so let's take a look at this.
It wouldn't be 2a up there.
No, because this length is not necessarily equal
Okay.
to from here to here. Okay. So what about this point right here? Where would that be? Well, it would be half of this, which would be a, right? And it would be half of this
B.
vertical line, which would be b. See why it was nice making this 2a and 2b? Because then it makes it really simple, you know, making it a. This could have been a over 2 and b over 2. It still would work. It just wouldn't be nice and pretty. All right. What about this point right here?
Negative a.
This would be negative a. And what? Is it negative b? No, so I'm still going up.
Still be B.
It's negative a because I'm going to the left. I'm still going up, so it's still positive b.
That's fine.
Do you agree? Now, what are we trying to prove? That the segments joining the vertices, these green ones right here, are congruent to each other. So how in the world can I prove that this green one is congruent to this green one right here? I've got the endpoints of both of them, so what should I do? Distance formula. Very good. So let's do distance formula and see what we get. So let's go from what did I tell you to do? Just draw it out?
Mine didn't even look like that.
I said just draw them out.
Yeah.
Yeah. Okay. Well, we're just doing this for fun anyway, right? So let's see if the distances are equal to each other. So from here to here, how do we find the distance? Put it into the distance formula. We do what to the x's? We subtract them, right? Yep, we do. So it's negative 2a minus a. Do that in your head. What's negative 2a minus a?
Negative 3a.
It's negative 3a. Okay, what about the b?
Negative 3. No.
0 minus b.
Is still B.
It's negative b, right? And we square it. So let's see what we get. This is going to be what? 9a squared. Not negative, because when I square negative, it's positive. Okay, plus what? B squared. So really, I don't have to simplify that anymore. Let's just keep it like that. So that's one length. Now what do I have to do to prove that the two lengths are the same? Do the same thing for the other green one. Let's just do that over here. You guys watching? So let's do this. Let's go put in the distance formula. Put that. 2a minus negative. What's minus negative? Plus. So that's 3a, isn't it? Let's do this. Doesn't matter what order. B minus 0, 0 minus b, which is b. Look what I get. I get 9a squared plus b squared square root. Look at that, and look at this. They're exactly the same, aren't they? So what did we just do? We proved that these two segments are equal to each other. All right, that's enough.